Good morning, my dear students. These are the contents in your syllabus. In last classes, data structures, definition, data structure operations, abstract data types we discussed, we learned. So today we want to discuss the complexity of algorithms, time and space complexities, array representations. Clear all of you. So before going to discuss complexity of algorithms, so we need to discuss last classes brief introduction. Then this is the data structure. What is a data structure? Simply, data structure is a particular way of organizing data in a computer so that it can be used effectively. This is an example for an array data structure. Then this is the classification of data structures. We know how many types, mainly two types. The first one is primitive and the second one is non-primitive. So come to this side, non-primitive data structures, linear data structures, non-linear data structures. Okay, linear data structures are arrays, linked list, stack, and queues. Then non-linear data structures are trees and graphs. So primitive data types, data structures, character, integer, float, and double. The non-primitive data structures, there are two types, linear data structures and non-linear data structures. Linear data structures means we can access or store elements in a linear order, linear fashion. Then these are the properties. Then the arrays, stacks, queues, and linked lists are the linear data structures. Already we discussed in the previous classes. So then the next one is arrays. This is an example for linear data structure. We know what is an array, how to represent an array. Then the next one, how to access, how to remove, how to then operations on arrays later we will discuss. Okay. Then stacks. Stack is the data structure. Yes or no? Linear data structure. Then there are two operations. Then insert and delete operations done at only one end. That is called the top end of the stack. Then this is called LIFO. LIFO means last in first out, which is the last inserted element, that is the first removable element. Next one is the queue. Queue is also a linear data structure. Then in the queue, there are queue have two hands, the front end and rear end. You're deleting elements from front end and inserting elements from into the rear end. Clear? Then the next one, linked list. Then these are also called dynamic data structures. Dynamic data structures. We can insert and delete anywhere in the list. Okay, Nama. Then non-linear data structures. Which elements are not arranged sequential are called non-linear data structures. Then these are the properties of non-linear data structures. Trees and graphs are the non-linear data structures. We will discuss in fourth and fifth units in detail. Okay. Then this is an example for a trees. This is an example for graph. What is a graph? Graph consists of number of edges and vertices. Then these are the differences between linear and non-linear data structures. Then operations on data structures. What are the operations on data structures? Most important question. Write and explain operations on data structures. Here simply, this is the traversing. Traversing means we want to visit each and every node in the tree, each and every node in the data structure. Visit every node in the data structure. Clear? That is called traversing. Inserting elements. So we want to insert a new element in the data structure. That is called insertion operation. Then delete operation. We want to remove an element from the data structure. That is called the delete operation. Searching. We want to find a particular element in the data structure or not. That is called searching. Then sorting, we want to arrange the elements either ascending or descending order. That is called sorting. Then merging, we want to merge two lists, two data structures. Then the resultant data structure is a one. Clear? That is called merging. Then these are all the operations on data structures. Clear? These are all the operations on data structures. Next one is abstract data type. We know what is the difference between abstract data type and data structures. Clearly, set of values and operations without specifying its implementation is called abstract data type. So abstract data type is a collection of values and a set of operations without specifying its implementation. That is called abstract data type. What is a data structure? Data structure is a way of organizing data. That is called data structures. Clear? These are the purposes. Then these are the data success: string ADT, list ADT, stack ADT, queue ADT, tree ADT, graph ADT, etc. These are all called abstract data structures. Next, these are the examples of abstract data type. Then the next one is today we want to discuss complexities of algorithms, a time complexity and space complexity. A complexities of algorithms, time complexity and space complexity. Simply, what is an algorithm? Simply, algorithm is a step-by-step procedure to solve a problem is known as algorithm. Step-by-step procedure to solve a problem is known as an algorithm. The complexity of an algorithm is function describing the efficiency of the algorithm in terms of amount of data the algorithms must process. Here, simple algorithm, step-by-step process to solve a problem is known as an algorithm. We know algorithm, infinite, finite steps of algorithm to solve a problem. Finite steps of to solve a problem is known as algorithm, or step-by-step procedure to solve a problem is known as algorithm. Then here quantities of good algorithms. What are the good qualities of algorithm? Here qualities of good algorithms are: the first one is input and output should be defined properly. Input and output should be defined precisely, clear. Simply what we want, then what are the requirements of the algorithm, clear. So first of all, we want to know the information regarding output. So based on the output, we finalize what are the requirements. Clear? Input and output should be defined precisely, clearly, okay, neatly, clear. Then the second one is each step in the algorithm should be clear and unambiguous. Then there is no ambiguity, clear. So we should define each and every step in the algorithm should be clear and unambiguous. Next one, third one is algorithm should be most effective among many different ways to solve a problem. Clear? Algorithm should be most effective among many different ways to solve a problem. There are many ways to solve a problem. Clear? Next one, algorithm should not include computer code. So computer code here, algorithm means general English language steps. General English language steps. Instead of, the algorithm should be written in such a way that it can be used in different programming languages. Once we have to develop an algorithm, based on this algorithm, we can develop the code in any programming language. Here, algorithm is not related to any programming language. Clear? Algorithm is not related to any programming language. All of you. Then the next one. Here, simply what is an algorithm? Algorithm, step by step procedure to solve a problem is known as algorithm. So then the best qualities, then there are four best qualities we discussed. Then the complexities of algorithm. What is complexity? What is time complexity and what is space complexity? Mainly there are two types of complexities. The first one is called time complexity, second one is called space complexity. So here simply program execution time. So how much time is required to execute a problem is known as algorithm. So how much time is required to execute a problem or program is known as time complexity. Then what is space complexity? Here space complexity, how much space is required to assign values in a particular program is known as space complexity. Space and time. Clear all of you. The complexity of an algorithm is a function describing the efficiency of the algorithm in terms of the amount of data the algorithm must process. Clear? Two types of complexities. The first one is time complexity and the second one is space complexity. Time complexity. The time complexity is a function describing the amount of time an algorithm takes in terms of the amount of input to the algorithm is known as time complexity. How much time is required? How much time is required to execute a program? That is called time complexity. Time means the number of memory accesses performed, the number of comparisons between integers, the number of times some inner loop is executed, or some other natural units related to the amount of real time the algorithm will take. For example, I want to display n in n numbers, natural from 1 to n natural numbers. I want to write a C program code. For example, for I is equal to 1, I less than or equal to n, I plus plus, display I value, then increment the I value by 1 itself, then repeat the loop. How many times I want to display 100 natural numbers from 1 to 100. Here a loop how many times repeated? 100 times repeated. And 101 time, the condition becomes false, the control exit. Yes, then here that is loop repetitions. How many times repeated? Clear. So how much time is required to execute a problem or a program is known as time complexity. The time complexity is a function describing the amount of time an algorithm takes in terms of the amount of input to the program. The time means the number of memory access performed, the number of comparisons between integers, the number of times some inner loops is executed, or some other natural unit related to the amount of real time the algorithm will take. Space complexity. Next one is space complexity. What is space complexity? How much space is required to store values in a particular program is known as space complexity. Here, space complexity is a function describing the amount of memory an algorithm takes in terms of the amount of input to the algorithm. Clear? We often speak of extra memory needed, not counting the memory needed to store the input itself. We can use bytes, but it's easier to use, say, number of integers used, number of fixed size structures, etc. Clear? Here, how much time is required to store input and output values, that is called space complexity. In the end the function will be independent of the actual number of bytes needed to represent the unit. Space complexity is sometimes ignored because the space is used is minimal. Clear? The complexity of an algorithm is studied with respect to the following three cases. There are worst case analysis, average case analysis, best case analysis. Worst case analysis, this is called, this is used to calculate upper bound calculations. Average case analysis, minimum. Then best case analysis here, average case analysis, lower bound values, best case analysis in medium analysis. What is worst case analysis? What is average case analysis? What is best case analysis? In the worst case analysis, we calculate upper bound on running time of an algorithm. Maximum running time of an algorithm is called worst case analysis. We must know the case that causes maximum number of operations to be executed. We must know the case that causes maximum number of operations to be executed. Number of repetitions, okay, number of loops. So maximum number of loops, that is called, that calculation is called worst case analysis. Then the next one is for linear search, the worst case happens when the element to be searched is not present in the array. For example, I want to call your CR. I want to call your CR, but he is not in the class. But I want to search from beginning, starting number 1 to ending number, last number, but he is not available. So here, when the worst case means I searched each and every student in your classroom. Clear? I so simply I searched each and every student in the classroom. Finally, he didn't in the classroom. Okay, ma. So simply, so I say he is not available in the classroom. Okay. So I mean the worst case analysis, it simply it can search all the elements in the given array, but search is not found. Clear? That is the worst case. Calculate upper bound value, maximum loops repeated. Then the next one is average case analysis. In the average case analysis, we take all possible inputs and calculate computing time for all of the inputs. Simply, so take all possible inputs and calculate computing time for all of the inputs. Here we sum all the calculated values and divided the sum by total number of inputs. We must know the distribution of cases. Clear? And next one, for the linear search problem, let us assume that all the cases are uniformly distributed. So we sum all the cases and divide the sum by n plus 1. So this is the average case analysis. Next one is best case analysis. In the best case analysis, we calculate lower bound value or running time of an algorithm. We must know the case that causes minimum number of operations to be executed. For example, in the linear search algorithm, I want to call a person. For example, I want to call in the classroom, I want to call roll number 15. So in the 15. So first of all, I want to search which is first sitting person. So his roll number 1 is not. So roll number 1 equal to roll number 15? No. Again, I want to search one by one. So when I went to roll number 15, so he is available in the classroom. Then no need to search the remaining 50, remaining 40 students. Clear? No need to search the why. Already search is found. So this is called best case. Clear? No need to execute the remaining elements. Clear, all of you? This is called best case analysis. In the linear search problem, the best case occurs X is present at the first location. Then no need to search the remaining elements. Clear? The next one, this is the most important question. Write and explain array abstract data type. What is an array? An array is a collection of same related data items with a common name. Clear? The array ADT is a set of values and a set of operations known as array. For example, what are the operations? Create, retrieve, store, etc. These are all the operations on arrays. Simply, what is an array abstract data type? A set of values and set of operations is known as array abstract data type. Simply, there are the operations. There are some operations available on arrays. So, array identity is objects, a set of pairs, index and value, where for each index there is a value, that is objects. Next one is functions. For all a belongs to array, I belongs to index, x belongs to item. Then here simply we should take an array. Array means integer a of 10. Integer a of 10. A is an array. I is the index value and x is an item. For example, a of 2 equal to 10. 10 is x. So a of 2 is an index. Then a is an array. So array creates j comma list. It creates a new empty array of j dimensions. Item retrieve of a comma I. It returns a value with index I in an array A if index is valid or an error if the index is invalid. Clear? Array stores a comma I comma x. It stores an item x with index I in an array A and array. Clear? So simply an array is a collection of same related data items with a common name. Clear? So then here the name of the array, then the next one index of the array, and x is an item of the array. For example, integer a of 10. Example, a of 5 equal to 20. 20 is a value, 10 is 5 is an index, a is an array. So array and its types. We know array is a collection of same related data items with a common name. Clear? Array is a collection of same related items with a common name. Clear? There are many types of arrays available in our data structures. Simply one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. What is one-dimensional array? One-dimensional array is a collection of a list of elements. Then what is two-dimensional array? Two-dimensional array is a collection of a table of elements. The table consists rows and columns. Rows and columns. Then multi-dimensional array, collection of two or more dimensions is called multi-dimensional array. Clear? Here single dimensional array. So this is a single dimensional array. An array is a collection of list of elements that are referred by a common name. An array is a list. An array is also called one-dimensional array or single-dimensional array. Here, single-dimensional array shows one dimension, either x or y direction. The array declaration, the syntax is data type variable name. The general syntax of the array declaration is data type variable name and size. Example, int is a data type where a is an array name. Then size of the array is 4. Here size of the array means here simply integer occupies 2 bytes memory. Then the total 4 blocks, each block size equal to 2 bytes. 4 into 2, 8 bytes memory allocated to A. 8 bytes means here each block size equal to 2 bytes. Simply array is a fixed length. Array consists of fixed length blocks. Clear? Each block size equal to 2 bytes. How many blocks are there? 4 blocks. How many values we can assign into A? 4 values. So each value occupy 2 bytes each block. That's why that is called fixed length block memory. In the above, integer represents data type. We know A represents name of array. Then size 4 represents number of elements in array. Clear? So this is one dimensional array. This is one dimensional array. So, array is initialized by as follows. The syntax is data type variable name size a list of values. Example, integer a of 5 equal to 10, 20, 30, 40, 50. Integer a of 5. 5 means here 5 values we can assign. So simply 5 blocks memory allocated to A. Clear? Then here 10 assign into 0 location. Then 20 assign into 1 index value, 2 index value, 3 index value, 4 index value. So we know array here starting with lower bound value 0 and upper bound value equal to n minus 1. Come here. The following example, here 10 assign into F0 location, 20 assign into F1 location, 30 assign into F2 location, 40 assign into F third location, then 50 assign into F4th location. Clear? Here x-axis or y-axis. So accessing the third element A of 2 equal to 30. Clear? This is one dimensional array. This is an example of one dimensional array. Integer A of 50. This is static memory allocation. At program timing time, at compilation time, the memory allocated to A, 100 bytes memory allocated to. This is the drawback. Whereas in linked list, then there is no wastage of memory. Whenever we want to insert, then automatically creating, first of all, we want to create, then assign into the value. Whereas in arrays, first of all, we want to allocate memory, the static memory allocation. Then we want to read, we want to store 10 values. What about the remaining 40 locations, wastage of 40 locations. Here sum equal to 0, average to find sum of n elements. This program is example program for to find sum of n elements. Here declaration of an array, then a single variable and another variable. Clear? Scan of how many values you want to read. For example, I want to read 5. Here for I is equal to 0, I less than n, I plus plus. Read 0 index value, the value assigned into A of 0 location. Here read 5 values. Then the next loop is used to find the sum of 5 elements. Then find the average value. Then it displays sum and average values. This is one dimensional array example. Clear? Next one is two dimensional array. What is two dimensional array? Two dimensional array is a collection of table of elements. Here table consists rows and columns. Clear? Horizontal lines and vertical lines. Horizontal lines are called rows, vertical lines are called columns. A two-dimensional array shows two dimensions x and y. It contains same typed values stored in both x and y directions. That is stored in a row column matrix form. The first index shows rows and second index rows columns. So this is an example of two-dimensional array. The general syntax here: variable name, data type, variable name, size 1 and size 2. Size 1 represents rows, size 2 represents columns. Example is integer a of 2, here two-dimensional array, 2 rows and 2 columns. Integer b of 3. B is a two-dimensional array. How many rows and how many columns? 3 rows and 3 columns. So from right to left, so first dimension represents columns and second dimension represents rows. From left to right, first rows, second one columns. Clear? And next one, initialization and accessing elements. So this is the general syntax. Initialization integer. Example is integer a of 2. How many rows and how many columns? 2 rows and 2 columns. Simply we will fill how many values? 4 values. 2 by 2, 4 values. 10, 20 first row elements and 30, 40 second row elements. Integer b of 3. Here how many elements possible to store? 9 elements. This is first row elements, second row elements, and third row elements. This is an example. So diagram, all of you. Then this is 2 by 2. How many? 0 and 1. Here lower bound value 0 and upper bound value 1. Here also rows, columns. Clear? Row 0, row 1. Here column 0, column 1. Here also 3 by 3 matrix. For example, I want to retrieve a value. First row, second column element. Which is the first row, second column element? So this is the first row and this is the second column element, 60. Clear? In the example, the accessing of a of 0 equal to 10. Here 0 row, 0 column element equal to 10. In the example 2, the accessing of b of 0 equal to 10. 0 row and 0 column value equal to 10. Clear? This is two-dimensional array. This is an example program for two-dimensional. This is the declaration a of 25, 25 rows and 25 columns. Clear? Then read first matrix values, table values, and find the sum of all elements in the table. Then find the average. Then display sum and average of the two-dimensional array. And multi-dimensional array. Multi-dimensional array is a collection of many directions, 2 or more directions. Multi-dimensional arrays can have or 3 or 4 or more dimensions. In array of 3 dimensions, the first dimension is called a plane, which consists of rows and columns. Arrays of 4 or more dimensions can be created and used, but they are difficult to draw. This is the general syntax of the multi-dimensional array: data type, variable name, size 1, size 2, size 3, so on, size n. This is an example for declaration of multi-dimensional array. Integer a of 2, 3, 3. This is the row. Then this is also internal row. This is columns. So come here. This is an example and initialization of three-dimensional array. Here integer a of 3, 2, 2. So how many values we can store? Here 2 into 2, 4 into 3, 12 values. This is first, second, third, fourth, fifth, and sixth. So here totally 3 main rows, but 2 sub rows and 2 columns. 2 sub rows and each one. Here 3 into 2 equal to 6 into 2 equal to 12 elements we can store in the multi-dimensional array. Clear? This is an example for multi-dimensional array. Here 0, 1, 2. Up total, this is 0, 1, 2. These are the columns. Each column divided into 2, 2. Each column divided into 2, 2. 2 rows and 2 columns. Here 0, 0, 1 value equal to 0, 0, 1. Here 0, 0, 0 value equal to 10. Here 0, 0, 1 equal to 15. Here 0, 1, 0 equal to 20. 0, 1, 1 equal to 25. This is called multi-dimensional array. Again, 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. Clear? Here 2, 0, 0. 2, 0, 1. 2, 1, 0. 2, 1, 2, 1, 1. Clear? So this is multi-dimensional array. So for example, I want to retrieve an element 0, 0, 1. Here 0, 0, 1 equal to 15. Clear? So this is an example program for reading and displaying and the sum. Find the sum and average values in the multi-dimensional array. Next one, representation of arrays. Representation of arrays. Tomorrow we will discuss. Okay, ma? All the best, all of you. Happy Ugadi. Enjoy. Happy Telugu New Year. Enjoy.